and includes features which improve efficiency, runtime, and operability. Spartan's design philosophy results in quick delivery and quality that exceeds industry standards. There are two main components to a typical amine treatment plant. The equipment on the amine regeneration skids processes rich amine into lean amine. The equipment on the gas skids processes sour natural gas with undesirable quantities of H2S and CO2 into sweet gas. Starting upstream from the gas skid, sour natural gas enters a two-phase separator to remove liquids from the gas. Then it continues to a filter separator to remove particulates. Next, the gas enters the gas skid. Treating continues with the skid-mounted fine filter separator for further removal of particulates. The sour gas then enters the bottom of the amine contactor tower, where it flows upwards, contacting a counterflowing solution of amine and water. This exothermic reaction is induced at high pressure and low temperature through either packing or trays in the tower, enabling the amine solution to remove H2S and CO2 from the gas. The treated or sweet natural gas flows out of the top of the contactor tower to an after scrubber, where any liquid picked up by the gas in the amine contactor drops out. After the gas leaves the gas skid, it then enters a gas cooler. When necessary, a dehydration system using triethylene glycol can be utilized to remove H2O from the saturated gas. The sweet gas now meets the customer's requirements. The amine regeneration skids process the amine output from the gas skids. The rich amine solution loaded with H2S and CO2 exits the bottom of the amine contactor tower at high pressure. Pressure is reduced and the amine enters the flash tank at a low pressure to flash off light hydrocarbons entrained in the amine. The low-pressure rich amine enters the amine regeneration skids. It is then filtered through three filters: a rich amine filter for particulates, a charcoal filter for hydrocarbons, and a charcoal afterfilter for removal of charcoal particulates. The rich amine is then preheated by a plate frame heat exchanger before entering the top of the still column. As the rich amine flows downward, it contacts counterflowing steam at low pressure and high temperature. The steam strips the rich amine solution of the H2S and CO2, leaving lean amine to exit the bottom of the still column and enter the reboiler. Inside the direct-fired reboiler, the lean amine solution is heated. The steam generated in the reboiler enters the bottom of the still column. This steam exits the top of the still column, flows through a reflux condenser, and then enters the reflux accumulator, where acid gas is separated from the water. The acid gas can be sent to a thermal oxidizer or disposed of in other ways. The water is recycled back into the system, being pumped into the rich amine solution by reflux pumps before it enters the still column. Back inside the reboiler, the lean amine flows over the top of a weir and into the surge side of the reboiler, where it exits and is cooled by the same plate frame heat exchanger that heated the rich amine. The lean amine is pumped by booster pumps into a lean amine cooler and into the solution pumps that pressurize it back up to high pressure. The lean amine then enters the top of the amine contactor tower, where the process is repeated. Spartan Energy Partners offers customers comprehensive solutions for treating and conditioning from the wellhead to the pipeline. Our experienced and dedicated team works with your organization to engineer solutions that will maximize gas flow and meet pipeline specifications. Through every step of our partnership, Spartan will assemble the right workforce with the right skills to meet your short and long-term operation and maintenance goals. Our team works hard to understand your production strategy and complement your team so you can focus on the aspects of your business that are important to you. We call this the Spartan advantage, a higher standard